Thank you. Thank you so much for having us. No, it was okay. I think everybody managed
Welcome, everyone. I'd like to introduce you all to my classroom assistant, Kamla.
Luceri, I must say, thank you for having us. This classroom looks beautiful.
Yes, Luceri, I love the decorations in this classroom. Now, tell me, are these examples of the children's own work?
Thank you, everyone. And yes, Claire, it is. I think it is important for the young children to see examples of their own work around the classroom. It also shows teachers that they don't have to spend a lot of money on pre-made posters and expensive charts to make the classroom beautiful. This works just as well, you know?
Yeah.
And I think this is the best place for you guys to observe, because then you'll be to sit, because then you'll be able to observe everything. Now, guys, if you'll excuse me, I have to fetch my class from where they're lining up. We'll be here shortly.
Okay. I wonder what would Zuki say about imperfect things on the wall. She'd probably want to make sure everything's perfect. Maybe even fix the kids' stuff.
Yeah. Zuki would know that this classroom space is for the kids to show what they're doing in class, not for the teachers. It's for the kids, not what some printing shop somewhere is printing out. Okay. Now, it would be very scary if the kids thought they have to be perfect products. I'd be worried.
Jerry, as a teacher, we have to think about what we put up on our classroom walls. You have to ask yourself, how does this add to the children's learning?
Why are Zuki and Norma anyway?
And Ziki. For us, they are the late ones.
Tsiki, Zuki, and Noma are in a play representing UJ in the Grahamstown Festival.
I wonder what part is Zuki playing.
Guys, before Lesedi comes in with the children, I need us to focus on today's topic. Okay? Now, I spoke to Lesedi and I told her that we're currently looking at the cardinality of number and decomposition. Now, she's going to be doing some work with the children that focuses on this. Okay? Now, Sibu, I want you to tell me quickly, what is cardinality of number?
Maybe I can help. Well, see, cardinal numbers tell how many there are of something. Like, for example, 1, 2, 3, 4, 5. It's 5 things. It's a hand. And it's important that kids use their hands. Matter of fact, it's natural. Like, for instance, I read somewhere that it is the natural transition from natural number knowledge. You know when kids only know up to the quantity of 3 objects, right?
Are you Zuki now?
What? I'm prepared, man. You know, Tep is not the only one who's trying to look good, you know.
Oh, we also learned something about fingers.
Oh yes, now I remember. Fingers are part of a body, and if kids use their fingers, they bridge from innate knowledge to symbolic knowledge when they work with symbols, when they use symbols to work with numbers.
Oh, I can explain. Before children can count objects, they spontaneously use their fingers. They just can't help it. It comes naturally. But then I think we mustn't stop them from doing that.
Oh, in fact, there is a tribe where guys use their body parts to show numbers.
But you are all making good points. Let's not ban the use of finger counting and using fingers to calculate. Now, I think at this point it's important for us to relate this back to the ideas of some of the theorists that we study. Now, Jean Piaget said that in the development of numeric concepts, the acquisition of the cardinal number concept, right, that is the understanding that a word number or an Arabic number symbol also represents a quantity with a specific number of elements, like 5. There is the word, and then there is also the Arabic code. Now, Piaget uses the example of a quantity of 7. And he says that if 7 objects have to be counted, each object has to be assigned a specific word number or an Arabic symbol, like 1 first, and then 2 objects. If you have 2 objects, you know that there's a way to describe it. It's now no longer 1, it's now 2 objects, okay? And if we have if all of the words that are used to describe the quantity of 7 are put together, we will have a number of 7, okay? Now, it doesn't matter if you have 7 that starts from 14 to 21, or that lies between 30 and 37. Okay? All of these numbers, when they put together, they all make up the number 7 anywhere on the number line.
And Marie Fritz. You remember the German developmental psychologist that Nziki spoke about last time? Well, she says that cardinal knowledge comes from an understanding of how groups are put together or broken up. So the smart term for this is composition of or segmentation of equal position. Now, these are units in a quantity. So the cardinal number 7 has 7 units. Now, Karen Fuzon wrote about this in The Origins and Nature of Children's Mathematical Skills. She says that when you break up a set, children understand how to add. They understand that a whole has parts. And when you add, you play with a part and a part that make up a whole. So if they have 5 units and they have to add 7 units, they can just count on from 5. So they can start at 6, then 7, 8, 9, 10, 11, 12. You see, I've just added on 7 units. I didn't start at 0 again. I didn't have to start from 0 like 1, 2, 3, 4, 5, 6, 7, 8, 9, la, la, la. I can just start from 6 and count on 7, 8, 9, 10, 11, and then I get to 12. And so I've added 5, counting on from 6. 7 is 7 no matter where you start. You can start at 3,482 and count on 7 units and get to 3,489. What you added is still 7. So let's hope Lesedi can demonstrate this.
Before the children get here, let's also quickly take a look at the meaning of the concept, the decomposition of number.
Decomposition. Isn't that what happens to dead bodies when they go all rotten and stuff?
KG.
Yes.
But KG, actually not too far off there.
Oh yeah.
Yeah. Right? Decompose means to break apart. So indirectly, this means that we take the numbers, or rather the quantity denoted by the numbers, apart. Like, for example, if you're looking at a quantity of 9, you can decompose it into the quantities of 4 and 5, or into 2, 3, and 4. Now, if you take those 3 groups, the group of 2, the group of 3, and the group of 4, together they still make a quantity of 9. Okay, now I hope that Lesedi shows this. Though this is a grade 1 class, she'll probably just stick to decomposing it into 2 parts.
Good morning, grade 1s.
Good morning, teacher.
Now, today we have some visitors, and they are students at a university. They're studying to become teachers, just like me, and I have told them what wonderful things you can do. I need you to please show them what wonderful things you can do. But firstly, I need you to say, good morning, visitors.
Good morning, visitors.
Good morning, kids.
All right, now let's all stand behind our chair and start with our morning exercise. Okay, first thing is first, and chop, chop, chop. Wonderful job. We can all sit down. Today, we're going to do something different. We are going to play a game. And in this game, I need you guys to listen carefully and give me answers. But boys and girls, you must raise your hand first when you give me an answer, okay? I'm going to firstly show you the magnets that I have in my hand. Do you all see the magnets? Good. Now, with these magnets, I am going to put 7 on the board. As I put them on the board, you're going to count with me how many they are, okay? Just to make sure teacher has them correctly.
1, 2,
Now, here is where it becomes a little bit tricky. I'm going to take some of these magnets off the board, actually all of them. I'm going to take all of them off the board and I'm going to put some behind my back and some in my hand. The ones in my hand I'm going to put back on the board. 1, 2, 3. So there are 3 magnets on the board. How many do I have behind my back to make it 7? Mia.
4 in your hand and 3, and then it makes 7.
Good girl. Yes, Mia. I have 4 magnets behind my back and we need 4 more to make it 7. See, Mia? 1, 2, 3, 4. And all together, they are 3, 4, 5, 6, 7. Well done, Mia. Now, I'm going to try with a bigger number. So I'm going to put these magnets on the board. But I only want 9 magnets on the board. How many more magnets should I put on to make it 9? Yes, Mia.
3.
3. No, my angel. Someone else? Yes, Tyler?
1.
To make it 9, my boy.
3. 5.
Look, I have 5 magnets on the board.
5. Another 5.
Let's make it 10, my boy.
4.
Let's see someone else.
4.
4.
8.
Oh, yes. Oh, how did you get the answer? You clever boy. You're right. We have 5 magnets and we need 4 more to put on the board so that they can make the number 9. 4 more magnets right here to make it 9 magnets on the board. Good. Now that I see you guys have the hang of it, I'm going to ask Teacher Kamla. Teacher Kamla, can you please help me hand out the papers that we glued on the bottle tops on yesterday? And my classroom helpers, where are my classroom helpers? Yes. Let's see. Ava and Ethan. Good ones. I want you to look at your sheets of paper and I want us to count the bottle tops at the top, okay? Remember, you cannot take them off. We stuck them down with glue, so please, boys and girls, you keep them on. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see, we have 9 bottle caps at the top. I need you guys to now take out the bottle caps. 9 bottle caps from your loose bottle caps bag. From your little plastic bag. Teacher Kamla, if you could just help them take out 9 bottle caps. Now, boys and girls, remember to put your little bottle caps in a pile off the sheet of paper, just on your desk in the little pile in the corner. Okay? And the first thing we're going to do, we're going to take 3 bottle caps from your bag. Now take 6 loose bottle caps, 6 boys and girls, and put them in the other empty block. Now, we need to all count how many bottle caps you have at the bottom and how many bottle caps do you have at the top.
There's 9 at the top and 9 at the bottom.
It's the same at the top, just as it is at the bottom. It's 9 at the top and 9 at the bottom. Now we're going to try again. Right? Take down all the bottle caps you put in the 2 empty blocks at the bottom. Only the ones at the bottom, boys and girls. So we're back in the state where it's your little pile again at the top corner. Nothing is on the sheet but the 9 blocks at the top. I want you to take 4 bottle caps and put them in one of the empty blocks. 1, 2, 3, and 4. Now take 5 more bottle caps and put them in the other empty block. 4 and 5. Now who can tell me how many bottle caps I have in this bottom part? Yes, Ethan.
9 at the top and 9 at the bottom.
Yes, there's 9 at the top and 9 at the bottom.
So, like, let's say this is all 9. And then when you break it up, it makes like it makes new numbers.
Numbers, good.
2 different numbers.
Okay, grade ones, you have done so well. I want you to please leave your bottle caps and the papers on your desk and stand in a row and follow teacher Kamla to your music class.
Please just roll all of us and stand here with teacher Kamla. Come all of us.
Wow, thank you. Thank you, Lissetti. That was a very interesting lesson. Would you mind if we ask questions?
Not at all, Jerry. Go ahead.
Oh yes, can I go first? Tell me, why did the children exercise before the beginning of the lesson?
Well, Sibu, you must remember that for all human beings, and especially for little kids, the brain and the body are so integrated. It is good for foundation phase children to kickstart their day with a little bit of exercise. I do this every morning with them because I think it helps them orientate themselves in the classroom. So it tells them that we are doing this in this space together and we are not outside anymore. And like I said, it helps them focus.
I like the way some of the objects were hidden. The student had to count on without actually seeing the quantity in your hand. Jerry explained that earlier on.
So, should we call you Zuki now?
Well done, Memani. At least somebody's listening. And there's a very good reason for this. You don't have to see all the units that make up a number. As long as you know they're there. The numerosity of 9 is always 9. Its cardinal value does not change.
Well, I like the way you organize the activity of the decomposition of a number. I mean into the top and bottom blocks. But I have to ask, why did you have them group 2 sets of 9 objects? Why not have them group 1 set of 9 objects?
Lissetti, is it okay if I answer him? Then you tell me if I understood it correctly. Please. Okay. You see, it's very difficult for children to understand the concept of a number once they've taken it apart into the different groups. I think it's better for the children if they have the visual aid in front of them so they can work with it and work with it on the blocks right there. So they can see that 9 still remains 9 no matter how you take it apart or no matter how you group them differently.
Yes, Claire. And in this way, the learners get to see the whole number and its 2 decomposed quantities. These 2 decomposed quantities also add up to this whole number. And in this case, this was the cardinal number of 9.
But why did you glue the top part?
Yes, Sibu, that is a good question. We actually glued the top part on because the learners either did 2 things. They lost the bottle caps or used it for the decomposition at the bottom. And in that way, the whole lesson lost its functionality and its impact. So teacher Kamla and I glued it so that the learners can see that this is a fixed quantity. It will remain fixed. And in this way, they could just work on the decomposition and 9 remains 9, it will always be 9, so work from there down.
So you teach them decomposition by breaking up the whole quantity into different parts?
Yes, Memani. And just as Lissetti did, one should remember not to always make 2 groupings, but also 3 or even more. Now, this paper didn't have space for 3, but then you could have different combinations, like add 2 or take away 1. But there's always parts and a whole. This is known as the part-whole concept in maths cognition.
So, how do you get these ideas? I'm also confused. What if parents asked how they can help the children at home?
I don't know if you know, that little girl who was sitting over there, Mia. Well, Mia's mother told me that she was baking with the children the other day, and she let them play around with the numbers and playing around while they're baking. Well, Mia's 6 and her little brother's 4. And what happened was that
Mia and Micah, we're gonna bake some chocolate chip cookies.
I love them, Mommy. That's my favorite.
Me too. Great. The first thing we have to do is measure out the flour. Micah, can you measure out 2 cups for us?
Yes, Mommy.
Mia, Micah measured out 2 cups. We needed 5 cups of flour. How many more cups do you need to measure out?
3 more.
Okay, can you do that for us? The next thing we need to add is some sugar. I have the recipe here, Mia. Could you read and tell us how much sugar we need to add?
Add 4 cups of sugar.
Brilliant. Micah, can you add 1 cup of sugar? Mia, Micah's added 1 cup of sugar. We need 4. How many more must he?
3.
Can you put that in the bowl for us?
1, 2, 3.
The next thing we need to add is the butter. We have 4 blocks of butter. Can you take half of this butter and put it in the bowl? Okay, that's a great try, Micah. I'm just going to pop it back in here and I'm going to ask Mia, do you know what half is? There's 4 blocks of...
2.
Wow, yes, 2. Can you put 2 in for us? Micah, can you put the other half in for us? We also need 6 eggs. Micah, can you count out 3 eggs for me?
1,
Fantastic. Mia, you need 3 more eggs. That's great. 6 eggs.
there you go, Mom.
Mia and Micah, are the biscuits ready to go into the oven now?
Yes. No, not yet.
What kind of biscuits are we making?
Chocolate.
Yes, we need the choc chips. Okay, count for us.
2, 4, 6.
Micah, can you put 6 choc chips in? Wow, Micah, it seems like you want a lot of chocolate in these choc chip cookies. Mia and Micah, look at the beautiful cookie dough we made. Now what we have to do is make small balls for our cookies, like this. And let's see yours. Sure, that's a little big. Let's break it. There we go. Try again. Mia and Micah, the cookies have cooled down. Come and taste. Delicious.
Now I feel like some chocolate chip cookies.
I KG man. You're supposed to focus on the maths concepts, not on the biscuits.
From what you've learned before, I find it interesting that Mika could not count out the chocolate chips, but just throw in a handful.
Yes, remember he still struggles with specific number value beyond 3. After 3 units, his understanding of how many objects exactly make up 6 is still a little bit fuzzy. He uses the approximate number system which we all have. We can all estimate quantities of a lot of chocolate chips or a few. So it's a lot or a few, same as more or less.
Yeah, because very young children, they already know the concept of a little or a lot. Like, for example, if you ask them to choose between a handful of Smarties in 2 different groups, a lot of Smarties and a little, they'll always choose the one that has a lot of Smarties. Now, very little children, they have the concept, they know of a lot and a little, but they don't know precisely how many beyond 3.
What I liked was the way the mom helped them estimate the sizes of the balls of dough. That was brilliant.
I also noticed that Mia could count on from the number of cupfuls which her brother placed in a bowl. She did not have to see those cupfuls again to add the 3 more. That means she counted on and understood the 5ness of 5, even though she could not see the cupfuls anymore.
Well observed, Memani. You see, Mia understood the cardinality of the number 5.
Well, guys, there goes the bell. I must fetch my children from their music class now.
Thank you so much. We must also go, but I think I speak on behalf of all when we say that today we saw theory in action.
Oh, yeah.
Yeah,
Really good.
cross-articulation theory.
Whoa. Thank you so much.
Thanks so much. Thank you.
Hey, coming up live. Our learning journey continues with mental chores. Now that we in chapter 4, it's time for us to learn more again. But now it's number decomposition and cardinality. I hope you're gonna listen. My listeners taught with strategy. The first area on which I will elaborate is number decomposition, because it's similar to division. You just take a bunch of stuff, separate it up. When you count it up, the total hasn't changed. You keep it up. Maybe you need you will assist or provide one. Say you have a dozen little fish and separate them into 2 groups of 5 and 7, then you count them. Tell me what's the total of the fish, still a dozen. Now that's handled. It's time to tackle cardinality from simple angles. You followed my first strategy, so on we travel. To leave this number concept mystery open and unraveled, and you know more baffled. See, what cardinality is, it's understanding that number symbols represent quantities without counting it. So when you write a numerical word or jot a digit, the quantity it's representing to you should be a give and take. The short example in my illustration, when you see a 5 written in a sum or a calculation, you know it's transferring meaning of 5 objects being the focus of your formula, skipping the counting, bruh. But bear in mind that when children have to count, use their fingers on their hands, calling all the numbers out, bridging symbolic and innate knowledge, using this route to learn how counting with numbers and symbols really works out.